Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to continue with chapter 5, development strategy. Okay, we are going to cover the second half of chapter 5, which is we are starting transit to system design phase, which includes system design guidelines, prototyping, and using codes during system design. Okay. The objectives of a system design phase basically is to make you understand how the software being designed before we can proceed with the development. So this is a system development life cycle. I just want to show you where you are now in the phase 3 of SDLC, which is a system design phase. So we start with the system design guideline. Okay, before you start doing a design for any systems that you are going to build, first and foremost, you have to know the system design guideline. Okay, the design guideline basically will guide you on how to set a design objective for the system that you are going to develop. And you will also have to know the design trade-off, right? Okay, trade-off here is referring to something that you have to give up or sacrifice in order to get something else. Okay, I think in terms of making decision for design system. Okay, firstly, the system analyst must understand the logical design, right? Before beginning the physical design of any components, which are data design, user interface, and system design specification. Please keep these three things in your mind. Okay. Okay. What is the objective of system design? Basically, the goal of system design is to build a system that satisfies business requirements. Okay. A successful system must be effective, reliable, and maintainable. So a system is effective if it produces the output that user wants, meaning that the system's functionalities support the business requirements and meet the user needs. System is reliable if it adequately handles error or failures, meaning that the system is always running very well and the functions do not make any failure. And a system is maintainable if it is well designed, flexible, and developed with future modifications in mind. Other design objectives which are very important are user considerations, data consideration, and architecture considerations. User considerations, the most important goal is to make the system user friendly. Okay, so here are the things that you have to keep in mind, which is carefully consider any point where users receive output or provide input to the system, which means the user interface must be easy to learn, input process should be easy to follow, and output should be attractive and easy to understand. Okay, anticipate future needs of the users, the system, and the organization. Provide flexibility. For example, we use a parameter which has a default value. Okay, for data consideration, data should be entered into the system where and when it occurs, because delays cause error. Data should be verified when entered to catch errors immediately. Okay, we are still under data consideration. Okay, automated methods of data entry should be used whenever possible, Access for data entry should be controlled, and all entries or changes to critical data values should be reported. We call it audit trails. Okay. Every instance of entry and change to data should be logged. Data should be entered into the system only once. And the last one is data duplication should be avoided. So all these are about data that we have to consider in designing the system. Okay. Now is architecture considerations. In addition to the issues that affect the users and data, you should consider the overall architecture. Okay. Here are some suggestions that you have to keep in mind by using a modular design or design modules that perform a single function are easier to understand, implement, and maintain. That's all about design objectives as your guidelines. Okay, design trade-off. Basically, you will find that design goals often conflicts, and you must consider alternatives and trade-off. As I mentioned, trade-off is something that you have to give up or sacrifice in order for you to get something else. For example, if you want to make a system easier to use, a programming requirement might be more complex. Another example, if you want to make a system more flexible, you might need to increase your maintenance requirements. All right. So basically, most design trade-off decision that you will face come down to the basic issue of quality versus uh, cost. Meaning that if you want to get low cost, then you have to sacrifice the quality, and you should avoid decisions that achieve short-term savings but might mean higher cost later. Okay, I think we are done on topic system design guideline. Okay, now we move on prototyping. But before that, our video code is 2992. Okay. Okay, prototyping produce an early rapidly construct working version of the purpose information system, which is called a prototype. Okay. Basically, prototyping allows a user to examine a model that accurately represents the system outputs, inputs, interface, and processes. Okay, usually, systems analysts use two different prototyping methods, which are system prototyping and design prototyping. System prototyping basically produce a full-featured working model of information system. Uh, Look at this first diagram. Shows you a system prototype ready for the implementation phase of SDLC. Okay. System analysts also use prototyping to verify user requirement, after which the prototype is discarded, and then the implementation continue, which is shown in this diagram. This approach also called design prototyping or throwaway prototyping. Okay. In this case, the prototyping objectives are more limited but not less important. So the end product of design prototyping is a user-approved model that documents the benchmarks, the features of the finished system. Okay, basically, prototyping offers many benefits, including the following. Okay, users and systems developers can avoid misunderstanding. Managers can evaluate a working model more effectively than a paper specification. Okay. Although most systems analysts believe that the advantage of prototyping, but you should consider the following potential problems. Okay, for example, the rapid pace of development can create quality problems. Okay, and in very complex system, the prototype becomes unwieldy and difficult to manage. Okay, prototyping tools. Okay, system analysts basically can use powerful tools to develop prototypes. Okay, for example, case tool, application generators, report generators, screen generators, and fourth generation language, 4GLs. Limitation of prototypes. Basically, the final version of the system typically demands the higher level performance than the prototype can provide. Okay, a prototype is a functioning system, but it is less efficient than a fully developed system because it is a model rather than a completed system. The prototype normally will have a slower processing speed and response times, and it also might lack with security exceptions and error handling procedure and other required functions. Okay, so system developer can upgrade the prototype into a final information system by adding the necessary capability. Okay, otherwise the prototype will be discarded. Other modeling tools, for example, system flowchart and American National Standard Institute (ANSI). This is the last topics covered in chapter 5, development strategy, which is using codes during system design. So a code basically is a set of letters or numbers that represent a data item. Okay, codes can be used to simplify output, input, and data format. So the overview of codes is because codes are used to represent data, you encounter them constantly in your everyday life. They save storage, space, and cost, reduce transmission time, and decrease data entry time. It is also can reduce data input error because coded data is easier to remember. Okay, these are types of codes. We have sequence codes, block sequence code, alphabetic codes, which is consists of category codes and abbreviation codes. Sequence codes basically is numbers or letters assigned in a specific order. For example, a student metric number. Okay, block sequence codes is a blocks of numbers for different classification. For example, code of course such as ISP ITS 332, ISP 640. Okay, so alphabetic codes is use alphabet letters to distinguish one item from another. Okay, for example of category code, SW is for software, HW is for hardware. And the example of abbreviation code is KL for Kuala Lumpur, WP is for Wilayah Persekutuan. Okay, we have other types of codes here, which is significant digit codes, which is codes that distinguish items by using a series of subgroups of digits. For example, phone number. Okay, Malaysia has a country code 60 in front of the number of the phone number. That's the significant code. We call it significant code. So derivation code is a combined data from different item attributes or characteristic to build the code. Okay. Cheaper code, use the keywords to encode a number. For example, BAG equal to 217, B is 1, A is 2, and G is 7. Okay, that's a cheaper code. Okay, action code indicates what action is to be taken with an associated item. For example, D is for display, E is for exit. Okay, the last one is a self-checking code. Okay, developing a code. Please keep the following suggestion in your mind when you're developing a code. Okay, the first one is keep code concise, allow for expansion, keep code stable, make codes unique, use sortable codes, avoid confusing codes, make codes meaningful, use code for a single purpose, and keep codes consistent. Okay, I think we have covered all topics in chapter 5, development strategies. So I think that's all. Thank you. Assalamualaikum warahmatullahi taala wabarakatuh.